Welcome, brothers. We are jumping right in today because we need to talk about the absolute lifeblood of our UPW systems, the Clean-in-Place or CIP procedure for ultrafiltration membranes. As operators and maintenance techs, you already know that UF is the critical pre-treatment gatekeeper in our ultra-pure water production line. When we nail this process, we literally protect every single thing downstream. So lock in. In this explainer, we're going to completely master exactly how to restore our membranes to peak performance and do it safely.
Here is our roadmap for today. We'll start with a quick system overview, move into why this is so necessary and the common mistakes we see out there, break down the detailed step-by-step procedure, and finally, wrap up with critical safety and key takeaways. Section 1. UF CIP System Overview. Let's do a quick refresher on our CIP skid. You've got your stainless steel holding tank, your pump and heater for locking in that precise temperature control, and your critical sensors for pH, flow, and pressure. But I want you to pay special attention to the cartridge filter on the return line. This thing is basically your membrane's bodyguard. When we're circulating chemicals and pulling dislodged foulants out of the module, that cartridge filter catches the hard particles so they don't loop back around and scratch those delicate hollow fibers. And obviously, always double-check that this skid is completely isolated from downstream equipment like your RO or mixed bed units. Now, when it comes to the chemicals, you have to tailor the weapon to the enemy. High pH alkaline solutions, those are for destroying organic and biological fouling. Low pH acid solutions, that's what you use to dissolve inorganic scale. But here is the absolute golden rule regarding material compatibility. Chlorine-based disinfectants can only, and I mean strictly only, be used on chlorine-resistant PVDF membranes. Never, ever guess on this. And when you're mixing up these batches, always use the good stuff. UF filtrate, RO permeate, or DI water. Using raw water is just going to introduce a whole new mess of contaminants right into your cleaning tank.
Section 2. Necessity and Common Mistakes.
Look, a really common trap guys fall into is thinking a routine backwash is enough. It's not. A backwash is basically just a physical rinse to knock off loose surface dust. To actually break down entrenched biofilms and hard scaling that gets cemented in there, you absolutely need the chemical action of a full CIP. It's the difference between simply rinsing a greasy pipe with water versus actually hitting it with a heavy-duty solvent.
So how do you know it's definitively time to pull the trigger on a CIP? Watch your transmembrane pressure, or TMP. When it hits that critical threshold of 1.0 bar, or whatever specific limit your OEM lays out, you have to act. Same goes if your normalized permeability drops by more than 20%. Waiting around just allows that fouling to harden and become completely irreversible.
Now let's talk about where things go wrong. Aside from relying way too much on backwashing, the deadliest mistake is using incompatible chemicals. Like we said, hit a PES membrane with hypochlorite and you will cause instant irreversible failure. Just total destruction of the polymer. Another huge one is pushing the pH out of the safe zone. PVDF is pretty tough. It'll handle a pH of 2 to 12, but other materials are much more sensitive. Also, do not crank up the flow rates during circulation, thinking it'll clean faster. It won't. You'll just snap the hollow fibers from sheer mechanical stress.
I want to burn this number into your minds right now. 35 to 40 degrees Celsius. That is your absolute ceiling. Exceeding this temperature limit during a CIP will permanently deform the membrane polymer and completely trash the module. Yes, heat accelerates chemical cleaning, which is exactly what we want, but too much heat literally melts our infrastructure. Watch that CIP heater like a hawk, brothers.
Finishing up our list of common errors, never rush your soak time. These chemicals need a solid 15 to 60 minutes to actually penetrate and do their job. Also, if you skip the forward flush and drain before starting the CIP, you're leaving a thick layer of loose sludge inside. That sludge will just react with your cleaning chemicals and turn into a hardened mess. And hey, if your system has an air scour feature, use it. That physical agitation supercharges your chemical cleaning. Finally, if you don't rinse properly or if you skip the post-CIP integrity test, you risk sending aggressive chemicals and bacteria from broken fibers straight into the RO system.
Section 3. Detailed CIP procedure. Grab your notepads.
All right, let's walk through the exact steps. Step 0 is your prep. Verify the data, figure out your foulants, and get your PPE on. Step 1, isolate the train. We're talking strict LOTO on all pumps and blowers and closing all raw water and RO valves. Step 2, do that forward flush we talked about, then drain it down to absolutely zero pressure.
Step 3, carefully mix your chemicals in the tank with pure water, get it heated to that sweet spot of 25 to 35 degrees, and verify your pH. Then Step 4, connect your temporary piping, making sure every single clamp is tight.
Moving to Step 5, kick on the CIP pump at a very low flow just to fill the module and vent all the air out. Circulate that for about 5 to 10 minutes. Step 6 is the main event, the chemical soak. Stop the pump, let it sit for 15 to 45 minutes, and pulse that air scour if you have it. Step 7, bring back active circulation and introduce gentle backwash pulses for about 30 to 60 seconds. You should actually see your TMP dropping here. Step 8, stop the pumps, open your drains, and route that waste for neutralization. And remember, if you are switching to a different chemical next, you must do an intermediate flush right here.
Step 9 is your high-flow flush with clean water until both your conductivity and pH drop back down to baseline. Step 10 is your ultimate quality gate, the integrity test. Run a pressure decay or bubble point test to prove absolutely zero fibers are broken. Step 11, pull your Lodo, remove the temporary connections, and slowly bring the train back online. Give it a light forward flush and check your turbidity before sending a single drop to the RO. And finally, Step 12, document the whole shebang. Log the date, your chemical recipe, your new baseline TMP, and your test results.
Section 4, Safety and Key Takeaways. Look, I know you guys manage both UF and RO systems, but you have to keep them strictly separated in your mind. A UF CIP is completely different from an RO CIP. UF operates at much lower pressures, it uses backwashes, it uses air scour. RO simply doesn't have those mechanisms. Plus, materials like PVDF and PES have completely different chemical thresholds than the thin film composites used in RO. Don't ever mix up the recipes or the procedures between the two. Apples and oranges.
Here are your absolute safety non-negotiables. First, never exceed your maximum TMP. You will rupture the fibers. Second, verify you are at zero pressure before you even think about touching those temporary hoses, unless you want a chemical bath. Third, never let those hollow fibers dry out. If they dry out, they turn brittle and fail instantly. Fourth, never mix your acid and alkali directly in the tank without a massive intermediate flush. It's a violent reaction and a recipe for disaster. Finally, keep your eyes on that return pressure. If it spikes, your cartridge filter is plugged or someone shut a valve. Hit the E-stop immediately.
So, what are the big takeaways today? Honestly, giving the chemicals enough time to soak is the single biggest factor between a successful clean and a complete waste of time. Second, always prove your membrane integrity before going back online. One broken fiber can send a massive bacterial shock straight to the RO plant. Third, track your TMP and permeability trends over the long haul, so you can catch this fouling before it turns into concrete. And lastly, talk to fab production. Taking a UF train offline chunks our total UPW capacity, so coordinate that downtime. Brothers, with these strict protocols and safety metrics locked in, are you ready to execute your next UF CIP flawlessly? The health of this entire UPW plant rests on how precisely you handle this exact procedure. Stay sharp, follow the steps, and protect our systems. Thanks for tuning in to this explainer. Keep up the great work out there.